guys, Nicole here from the Exam Revolution team, and in this meteorology video we are going to be discussing coded weather reports, and we will be covering the following topics. We'll have a look at aviation weather reports, METARS species, we'll have a look at TAF, SIGMET, AirMet, and then aviation weather broadcast. Now let's have a look at aviation weather reports. Now, weather reports are in high importance to pilots, and there's a worldwide standard to what is reported and which formats are used, and a set of codes have been created to standardize the messages to suit aviation. So this means no matter where you go in the world, all coded aviation weather reports will be exactly the same standard and format for your interpretation. And it is the responsibility of the pilot to make sure that all relevant weather sources that contain information that is relevant for the flight are checked. Now let's start and have a look at the first weather report called a METAR. Now a METAR is a meteorological aerodrome report and is the actual weather for a specific location. It is updated every 30 minutes, and if significant weather changes take place during this period, a specie is issued. So this is an example of a coded METAR or aviation report. So it doesn't contain a lot of words or letters. However, it does contain, once decoded, it contains a lot of information pertinent to your flight. The METAR and specie are in exactly the same format, so exactly the same format that you saw in the previous slide. However, the METAR is routinely updated and the specie is only issued if the conditions in the METAR have changed significantly. Now let's have a look at a coded weather report, and we'll go have a look at each section in quite a lot of detail. So we start with the name, which indicates the type of report that we are looking at. So METAR is the code name for the type of report, which is Meteorological Routine Aerodrome Report. And a specie, because it's just giving us information with a significant change in the METAR, is a special Meteorological Routine Aerodrome Report. Now the first section there is COR, and that indicates a correction. Now, COR is not included in every report. It is only included if a correction to the previous report was made. So if there was a mistake or error on the previous METAR, the next METAR will be issued with the letters COR to indicate that there was a correction. You can also have the words auto included in the report, and is used in the report when it came from an automated source without any human intervention. The next section is location, so FACT. So FACT is a 4-letter code issued by the International Civil Aviation Organization, and it's to indicate the airport location. Now in South Africa, all registered airports have a 4-letter code, and all codes start with FA in South Africa, and the last 2 letters is unique to that specific airport. So CT is unique to Cape Town International. So this report is for Cape Town International Airport. Johannesburg will be FAOR for OR Tambo International, and so on. The next section is day and time. Now the METAR does not give a month or a year, it simply gives the day of the month and time in hours and minutes of the information in UTC or Zulu time. Now because this is Zulu time, we'd have to convert this time to our local time if we want to know what it is in local time. Now just have a look at the map very quickly. You'll see in the very center is UTC. Now every 15 degrees change in latitude means there's an hour change in time. And all of these, it's called zone time, and all of these zone times have an alphabetical letter to indicate the zone time. So if you go east of UTC, the UTC plus 1 hour plus 2 hours will indicate an increase in the time. If you go west, it's UTC minus 1 hour. So if you look at South Africa, it falls in UTC plus 1 hour and UTC plus 2. But South Africa has a standard time of UTC plus 2, and that's called Bravo time. So UTC plus 1 is Alpha, UTC plus 2 is Bravo, UTC plus 3 is Charlie, and so on. So South Africa is UTC plus 2. So if we'd like to convert that time that you see in this example to local time, we simply add 2 hours. So therefore, it was taken at 7 o'clock local time. If an element cannot be observed in a group, so this often happens when it's an automated station and certain elements of the weather report cannot be obtained, like wind speed and direction or cloud information. The group which can't be reported is then replaced by the symbol /. So if you look at this example, you'll see that you've got auto and the wind direction and speed, and then the rest of the information that's missing is replaced by a series of /. Okay, the next section that we're going to have a look at is wind direction and speed, and there's many variations in the way that wind direction and speed can be reported. Now, wind direction is rounded off to the nearest 10 degrees in degrees true. So in this example, the first 3 numbers represent the wind direction. So that is 0, 1, 0 degrees, and that is in degrees true. So remember, the wind is coming from that direction. So the wind is coming from 0, 1, 0 degrees, and therefore we can call it a northerly wind. The 2 numbers after the wind direction, 18 or 18 knots, is the mean wind speed over the 10 minutes preceding the observation in knots. So that reads 010 degrees, 18 knots. Now, as mentioned, there's many different ways that the wind can be reported depending on the wind. So one of those variables is variable wind. Now, the direction of the wind will be substituted by the letters VRB if it varies by more than 60 degrees, or if the wind speed is less than 3 knots, or if the wind direction cannot be determined. So if you look at the example, FAPE, the location, the day and time, and then your wind group is replaced by the letters VRB, variable wind, because the wind direction has changed by more than 60 degrees, and or the wind speed is less than 3 knots, or the wind's direction cannot be obtained. Now, another condition of wind could be calm conditions, and it's usually indicated by 5 zeros. If we look at gusting, if the wind gust speed during the 10 minutes preceding the observation exceeds the mean wind speed by 10 knots or more, G is added after the average wind speed indicating a gust. So in our example, we've got wind direction 010 degrees, 18 knots, gusting 32 knots. So 10 minutes before the observation was made, the wind speed was exceeded by a gust of more than 10 knots. So 18 knots, gusting 32. We can also have a variation in the wind reported. So variation in wind direction is given in a clockwise order when the variation is between 60 degrees or more, but less than 180 degrees, and the wind speed is more than 3 knots. So you'll still have your wind direction and speed, but it will indicate a change in the wind direction as variable. So this example will read your location, your day and time, and then your wind direction is 300 degrees, 22 knots, gusting 33, and the wind is variable by 240 degrees and 015 degrees. So remember, once again, the 2 blue arrows indicates the 2 extreme of the wind direction change. So we've got 240 degrees and reported in a clockwise direction, therefore the next wind direction is 015 degrees, and the red arrow indicates the average wind direction. Okay, the next section is visibility. Now, once again, this can contain a lot of different ways to report visibility. So let's have a look. So the actual visibility in meters is reported, and the code 9999 indicates visibility greater than 10 kilometers or 10,000 meters. However, if the visibility is less than 10 kilometers, so let's say it's between 0 and 500 meters, then the visibility is reported or rounded down to the nearest 50 meters. So if the visibility was measured at 490 meters, it would be reported as 450 meters. Now, the greater this visibility becomes, the greater the rounding off becomes. So let's have a look. So 500, if the visibility is between 500 and 5,000 meters, it's rounded down to the nearest 100 meters. So if the visibility is measured to be 4,780 meters, it would be reported as 4,700 meters. And again, if the visibility is reported between 5,000 and greater than 10,000 kilometers, 10,000 meters, it's rounded down to the nearest 500 meters. So 6,880 meters would be reported as 6,500 meters. So when the horizontal visibility is not the same in all directions, and the visibility in a certain direction is less than 50% of the prevailing visibility, then the direction of the lowest visibility is indicated. Let's have a look at an example. So here we've got a northerly visibility of 2,500 meters. Easterly visibility 6,000 meters. Southerly is also 6,000 meters, and westerly visibility is also 6,000 meters. So because the lowest visibility is less than 50% of the prevailing visibility, the lowest visibility is reported. So you can see in our example, you've got your location, day and time, wind, and then the visibility is reported as 2,500 meters to the north. However, where the visibility is less than 1,500 meters in one direction, but greater than 5,000 meters in another, then the maximum is indicated. So in this example, you see a northerly visibility is 800 meters and an easterly visibility is 6,000 meters. The greater visibility will be reported of 6,000 meters. Now we're going to have a look at runway visual range. Now this is not exactly important to the visual pilot or VFR pilot. However, you need to be able to interpret a METAR to determine when it's giving you runway visual range. Now, runway visual range will be given when the horizontal visibility is 1,500 meters or less. So why I say that doesn't really apply to a VFR pilot, because VFR pilots require 5,000 meters of visibility or more. But it's important that you are able to interpret the METAR when RVR is given. So runway visual range is the distance over which a pilot of an aircraft on the center line of the runway can see the runway surface markings indicating the runway or identifying its center line. Now, because the visibility is so reduced, it's important for the pilot to be able to ascertain whether this visibility is good enough for takeoff. Now, the pilot, if we do not have equipment that can measure the runway visual range, the pilot can do assessment himself. And this is by standing at the threshold of the runway in the aircraft and counting how much lights you see. So we will know the distance of each light, and therefore if we count the amount of lights, we know the visibility down the runway. Now the runway designator, when RVR is reported, the runway designator is reported first, followed by the average visibility in the last 10 minutes in meters. So if you have a look at this example, you've got your location, FAPE, day and time of the observation, wind direction and speed, and then your RVR is reported as runway 03 left, visibility is 800 meters. However, there may be fluctuations in the visibility on the runway or RVR. So if RVR is fluctuating, the letter U would indicate increasing visibility, the letter D would indicate decreasing visibility, and the letter N means there's no change in the visibility. So if we'll have a look at our example once again, it's runway 03 left with an 800 meter visibility decreasing, and runway 03 right has 1,200 meters of visibility with no change. If significant variations occur, a minimum and a maximum value is given, which is separated by the letter V. So have a look at this example. We've got varying visibility with a minimum and a maximum value. So it will be runway 03 left and the visibility, or RVR, is varying between 500 meters and 700 meters. Now, as mentioned before, if there is no equipment to measure this visibility along the runway, then the pilot has to assess it for himself. However, usually what values are given in the meteorological, or METAR, is given by the transmissometer. So if actual RVR values are outside the measuring range of this observing system, which is the transmissometer, then P1500 is more than 1,500 meters visibility, and M50 indicates visibility less than 50 meters. So these are your transmissometers along the side of the runway, measuring the visibility along the runway. So in this example, if RVR is greater than 1,500 meters, then P is used. And if we look at this example, runway 03 left, P 1,500 means the visibility greater than, or RVR is greater than 1,500 meters. If the RVR is less than 50 meters, then M is used. And you can see in the example, runway 03 left, M50 or 50 indicates that the RVR is less than 50 meters. Okay, the next section we're going to have a look at is present weather. Now, if there is no present weather to report on, this is just left blank, or it is not included in the report. So present weather, when between the visibility and RVR and cloud groups, you might find a group containing the present weather only included if such weather exists. Now, in your exam, you will have a booklet, or meteorology booklet, in which you will have a table with all the abbreviations, and you will also find it available for download in this module. And this will contain all of these weather codes. You do not have to go and study and memorize all of these codes. It will be available during the exam. So this is what you would see, and it starts with intensity in column 1. So you can see a minus would indicate light, and heavy or plus would be indicated by plus sign, VC in the vicinity, and then you've got various codes which you can just refer back to any time that you have present weather in your reports. Now, as mentioned, in present weather, codes can have a plus indicating heavy or a minus indicating light. When there is no qualifier, it indicates moderate. So if the present weather is rain, if you have a plus in front of it, it's heavy rain. If you have a minus in front of it, it's light rain. No qualifier, it's moderate rain. Okay, the next section we're going to have a look at is your cloud amounts and your cloud heights. So cloud amount is reported in octaves, and the height of the cloud base is reported in hundreds of feet above ground level. So just remember, when you fly, you have Q and H set in your altimeter, and that indicates height above sea level. But when you read the weather report, or METAR, the height of that cloud is measured in feet above ground. So remember that in order to determine the cloud amount, there's an observer that divides the horizon that you can see into 8 equal parts, and depending on how much cloud coverage there is, will give us a code for the amount of cloud coverage. So remember, few cloud is 1 to 2 octaves, scattered cloud is 3 to 4 octaves, broken cloud 5 to 7, and overcast is all 8 octaves are covered in cloud. So here we have an example. We've got 1, 2, 3, 4, 5 out of the 8 octaves covered in cloud. So what is the cloud amount here? Well, few is 1 to 2, so it can't be that. Scattered is 3 to 4, and broken is 5 to 7. So this is broken cloud, and on the left lower part of your screen you can see the altitude. So this would be broken cloud at 4,000 feet. Now, vertical clouds, so cloud types are not usually reported, but vertical cloud types are always reported when observed, and they are the only cloud types reported. So cumulonimbus is reported as the letters CB, and in this example, you've got scattered cloud at 1,900 feet. So I always add 2 zeros after the number to help me remember the value of the number. So scattered cloud at 1,900 feet, broken cloud at 4,000 feet. So remember to add the 2 zeros, and CB indicating cumulonimbus cloud. The code for towering cumulus is TCU, and once again added to the end of the cloud amount and cloud height. You could also have the letters DIF for diffused, RAG for ragged, and FLUC for fluctuating after the cloud amount and height. Now, DIF will be used when the base is diffused, meaning it's spread all over. Ragged meaning uneven, so could it be indication of turbulence, or fluctuating using the letters FLUC. Okay, then we have special codes that replace certain aspects of the report if certain weather conditions exist. And one such code is CAV-OK. So CAV-OK replaces visibility, present weather, and cloud amounts if the following conditions exist. So if the visibility is 10 kilometers or more, there is no cloud below 5,000 feet or minimum sector altitude, whichever is greater, and no cumulonimbus, and no significant weather phenomena. So remember, when the code CAV-OK is used, it means that it's very good weather, and it replaces visibility, present weather, and cloud amount. So for CAV-OK, it means ceiling and or visibility is okay, and it means that this visibility is greater than 10 kilometers, no clouds below 5,000 feet, or MSA. MSA is minimum sector altitude. So that simply is the highest terrain within 25 nautical miles of an airport, and you add 1,500 feet to that. So let's say the MSA at Cape Town International is 6,000 feet. Sorry, the highest terrain is 6,000 feet. So therefore, if we add 1,500 feet for mountain clearance or terrain clearance, the MSA would be 7,500 feet. So that means there's no cloud below that. So therefore, you're able to see terrain, because as a visual pilot, it's very important to keep yourself clear of terrain and other aircraft. And then there's no cumulonimbus cloud and no significant weather present. Another type of code, or another code which can replace your visibility, recent weather, and cloud amounts, is NSC. So that stands for no significant cloud. And as mentioned, it replaces visibility, recent weather, and cloud amounts. There is a slight difference, so it's almost the same as CAV-OK, but with slight differences. So there's also no cloud below 5,000 feet or minimum sector altitude, whichever is greater. There's also no cumulonimbus cloud, but here's the difference. The visibility is less than 10 kilometers, and there is weather present, significant weather present. Okay, then the next section is temperature and dew point temperature. Now it's the observed temperature, and the dew point temperature rounded up to the nearest whole degree Celsius is shown, and minus is indicated by an M. So for example, if the temperature is 15 followed by M03, it means minus 3 degrees. In our example above that, our temperature is 12 degrees followed by a dew point temperature of 9 degrees. Now, the difference between the temperature and the dew point temperature is quite significant to us. The difference between temperature and dew point is called a temperature-dew point spread. The difference indicates how close the air is to being saturated. So that means if you look at this example, you've got a temperature of 16, dew point of 15. So you can see they're quite close together. So that simply means that the outside air temperature of 16 just has to cool to 1 degree for the air to become saturated, and any further cooling would then result in the water vapor condensing into cloud. So this could then indicate to you that low cloud or fog is likely to form. Okay, then the next section is QNH. So QNH is the mean sea level pressure reported in hectopascal. When set on the altimeter, it indicates height above sea level. So remember, on your altimeter, in your window, you will set the QNH for the day, and that will indicate your height above sea level. Okay, not always present in the weather report, but recent weather can also be reported, and it will start off with RE indicating that it's recent weather and refers to weather phenomena which is important for aircraft operations. So in this example, you've got your temperature and your dew point, your QNH, and then recent weather, RESH. So if you encounter this in the exam, simply just go to your table and we look for SH. So that means there's showers. So now we know that there was recent showers, which then could indicate to us that there's a wet runway, and therefore that braking would be slightly decreased. So anything that would affect aircraft operations. Now, wind shear is another such report which can affect aircraft operations. So wind shear can be reported if along the takeoff or approach path is affecting all the runways. So the code wind shear all runways is used. So if you look at the example, wind shear all runway is what you'll see if you have wind shear along the takeoff and approach path. Now, wind shear can cause significant difficulties in trying to land the aircraft. So if you're approaching and you experience a headwind, the aircraft performance is increased, so you might have to lower the nose and decrease power. However, as the wind direction changes to almost a tailwind, now you experience a decrease in aircraft performance. So this then causes the aircraft to sink too fast, so it creates an unstable approach and also a very dangerous situation when wind shear is significant. Okay, and the last section of the METAR is the trend forecast. So a trend is a short-term forecast or an outlook based on the current weather conditions given at the end of the METAR. And very importantly, it's only valid for 2 hours from observation. It's often referred to as a landing forecast. Now, a trend forecast, like no sig in our example, so it's signifying no significant change in the weather. However, we could also have something called a probability followed by a percentage. So probability that temporarily there's going to be a fluctuation in the weather. So it's a probability expressed as a percentage, and only 30 or 40% is used if there is a temporary fluctuation in the weather expected. If there's a higher probability of this temporary fluctuation happening, then only the word tempo is used for temporarily. So you'd have something in the weather report saying there's probability 30% chance that temporarily the cloud base and visibility will decrease. So remember, if there's a greater chance than 40% for a temporary fluctuation in the weather, then only the word tempo is used. So temporary is used when temporary fluctuations are expected to be less than 1 hour at a time, and in total less than half the period forecast. So in a METAR, remember, this is only valid for 2 hours. So if there's a temporary fluctuation in the visibility, for instance, let's say there's a decrease in visibility, it will only be less than 1 hour at a time. So you'll have a fluctuation in visibility for less than 1 hour at a time, and for that 2 hour period will only be for half that period in total that this fluctuation will take place. Obviously, if longer periods are forecast, let's say 4 hours that this fluctuation will happen, then it will only be for 2 hours in which this fluctuation in weather would change. Becoming is a gradual change in some of the forecast elements that is expected, and again it's a 2 hour period given in which there's a gradual change predicted. Okay, then lastly, remark can be added to the end of a METAR with the words RMK. The observer may add a remark that was observed. For example, you've got your QNH and then the words RMK remarking that there was thunder at the airport. And the equal sign at the end of all the reports equals the end of that report. So let's have a look at a few examples. So this is obviously a METAR, the location, FAGG, which happens to be George. Now we have the date of observation, so on the 20th at 7 o'clock Zulu. If we'd like to convert that to local time, it's add 2 hours, so it would be 9 o'clock local time. The wind is calm, so indicated by the 5 zeros. Then it's visibility. It's great is 1,000 meters. And then we've got VCFG. Once again, you do not have to memorize these codes. We simply go to the book, and you've got VC, so that means in the vicinity, and FG in column 4 means fog. So there's fog in the vicinity with few clouds at 0 feet. So that makes sense because there's fog. There's another layer of cloud, of broken cloud. So remember to add the 2 zeros. So that will be broken cloud at 2,500 feet. The temperature is 16, dew point is 15. So that makes sense because there's fog in the area. And the QNH is 1022, and the equal sign indicates the end of this bulletin. Okay, another example here, we have a METAR for Uppington. Observation is 20th, 7 o'clock Zulu. Wind is 210 degrees, 5 knots. It's Cavo K. So remember, Cavo K is visibility is greater than 10 kilometers, and no clouds below 5,000 feet or minimum sector altitude, no cumulonimbus, and no significant weather. Temperature is 21, dew point -1, QNH 1019. Another example, FAGM. It's 20th, 7:30 Zulu. Wind is 070 degrees, 10 knots, 6,000 meters visibility, and now we've got BR plus. If we go to our table, in the first column we've got plus indicating heavy or well developed, and in column 4 we've got BR for mist. Then we've got broken cloud at 5,000 feet, overcast at 2,000, QNH 16, dew point 15, and the QNH is, the temperature was 16, the dew point was 15, QNH 1025. Okay, so let's move on and have a look at a specie. Now, a specie is a special aeronautical report, and it's encoded in the exact same way as a METAR, but it's issued immediately when there's a significant change in the weather observed. Now, obviously, there's parameters or standards of how much the weather has to change before a specie can be issued. And let's start with wind. So when the mean wind direction changes by more than 60 degrees, or the mean wind speed changes by 10 knots or more, or gusts of 10 knots or experience, or greater than 10 knots or experience, then the specie is issued with the new information. If the visibility changes to or passes 800 meters, 1,500 meters, 3,000 meters, or 5,000 meters, a specie is issued. So if the visibility increases by these amounts or decreases below these amounts, this will then prompt a specie to be issued. Similarly, if the RVR changes to or passes 150 meters, 350 meters, 600 meters, or 800 meters, a specie is then issued. Cloud base, so when the base of the lowest layer of broken or overcast, so note that it's only when there's a change in the lowest layer of broken or overcast, it changes or passes 100, 200, 500, 1,000, or 1,500 feet, then a specie is issued. Okay, so that was cloud base. When cloud amount changes, so when the amount of cloud below 1,500 feet changes from no significant cloud, few scattered, changes to broken, or the other way around, where it starts to clear up from broken or overcast, it starts to go to no significant cloud, few cloud, then a specie is issued. Okay, vertical visibility. Now, if the sky is obscured, and this would be to fog, mist, or haze, and the vertical visibility changes or passes 100, 200, 500, or 1,000 feet, a specie will then be issued. And if there's an increase in temperature of 2 degrees Celsius or more, we will have to issue a new specie. Okay, let's have a look at the TAF. Now, the METAR was the actual weather at an airport, and the specie was only issued when there was a significant change in this actual weather. Now, a terminal aerodrome forecast follows the same format as a METAR, but may include additional items such as forecast, temperatures, expected icing conditions, and turbulence. So I'm not going to go through everything again. We're just going to go through the changes that you'd see in a TAF. So TAFs are valid for less than 12 hours are issued every 3 hours, and those valid for more than 12 hours are issued every 6 hours. So remember, a terminal aerodrome forecast is a forecast of the weather, so it's valid for a longer period of time. So when a TAF is amended, so if there's a change in the weather or there's a correction, AMD is added to before the report. So in this example, you've got AMD, so that means amended, the TAF for Cape Town, and so on. It goes on with the report. So let's have a look at this example. So remember, we said that it's valid for a certain period of time, and it will tell you the period of time that it's valid from. So a TAF has a date and a time of issue, but also a time of validity. So in this example, it's issued on the 27th at 2300 Zulu and is valid from the 28th, 6 o'clock Zulu to 1500 Zulu. If you find the words null in your report, your TAF, null indicates missing information, if not available, or it's not received. So that information is just missing if null is included in your report. Okay, the next example that we have with the TAF is that it has a trend forecast. Now, very similar to the METAR, the same probability, temporarily, and becoming is all included in the TAF, but now we have a time period. So the trend forecast for the TAF includes a time period in which the change will start and end. So in this example, temporarily, there's going to be a change in the weather between 6 o'clock Zulu and 8 o'clock Zulu, and then it will give the change in the weather. The visibility will decrease to 5,000 meters. You will experience light rain, and that's going to be the temporary change in the weather. Okay, in addition to the trend forecast, it will also, a TAF will give you a time from. So FM indicated on your report or in your report, from can be used to indicate a specific time when these weather changes will occur. The report will include the date, time in hours and minutes of the expected change. The words LT indicates the end of the temporary weather fluctuation. So that means until. Okay, let's have a look at your temperature and your maximum and minimum temperature. So the maximum and minimum temperature for the day is reported, including the time of day and the time that this will occur. So in this example, you've got TX29. So that means maximum temperature of 29 degrees Celsius, which will be experienced at 12 o'clock Zulu. And TN12 is the minimum temperature of 12 degrees Celsius, which will happen or be present or be experienced at 1800 Zulu. So let's have a look at some examples. So this is a TAF, Terminal Aerodrome Forecast, and it was issued on the 20th at 6 o'clock Zulu, and it's valid from the 20th at 7 o'clock to 1800 Zulu. The wind is 340 degrees, 10 knots. Visibility is greater than 10 kilometers. You've got broken cloud at 2,000 feet, becoming from 10 o'clock Zulu to 12 o'clock Zulu. Few cloud, 3,500 feet, Charlie Bravo's cumulonimbus cloud, and then scattered cloud at 4,000 feet. Then there's a probability of a 40% chance that temporarily you're between the 12 o'clock Zulu and 1800 Zulu, that the visibility will drop to 5,000 meters. TSRA, once again, you don't have to remember this, just go back to your code in your exam booklet, but that is thunder showers and rain. Then you'll have broken cloud at 5,000 meters, a maximum temperature of 29 degrees at 12 o'clock Zulu, and a minimum temperature of 18 degrees at 1800 Zulu. So once again, this is going to be in your exam, so you do not need to remember those codes. As you keep on doing more and more of these, you'll start to remember or memorize these codes. Okay, another example of a TAF is taken or issued on the 20th at 6 o'clock Zulu. Oh, sorry, this is the same one. So we'll just carry on from there. This is a new one. So issued on the 20th at 6 o'clock Zulu. And it's valid from the 20th at 7 o'clock to 1800 Zulu. The wind is 210 degrees, 15 knots. We've got 9,000 meters visibility, and we've got the code HZ. So we just refer back to our code, and we're looking for HZ. Okay, so there we have HZ in column 4, and that is haze. So then we've got scattered cloud at 1,000 feet, broken cloud at 2,000 feet. Then there's a probability, that 30% chance, that temporarily between 7 o'clock Zulu and 10 o'clock Zulu, that the visibility will decrease to 4,000 meters, and we will experience minus, so light, DZRA. So that would be drizzle and rain. And then broken cloud, 800 feet, becoming from 11 o'clock Zulu to 1300 Zulu. Visibility will be greater than 10 kilometers, so the weather is improving. You'd have scattered cloud at 1,500 feet, broken cloud at 3,500 feet. So the bases of the clouds are definitely lifting, and there's a probability that 30% chance that temporarily later in the afternoon, between 1600 Zulu and 1800 Zulu, that the cloud base will once again decrease to 1,500 feet. Maximum temperature is 26 on the 12 o'clock Zulu. Minimum temperature is 22 at 1800 Zulu. Now let's have a look at the SIGMET. Now a SIGMET is information concerning the occurrence or expected occurrence of specified en route weather phenomena, which may affect the safety of the aircraft operations. So this could be thunderstorms, volcanic ash, anything that will affect the aircraft en route. Now, SIGMETs are classified as either convective or non-convective and valid for 4 hours and are issued hourly. Now, convective, remember that's thunderstorm activity. Non-convective will be something else. So, convective SIGMETs issued when there are convective activities in certain areas. That would be conditions such as embedded thunderstorms, a line of thunderstorms, so a score line of 96 kilometers long, so that's quite significant. Level 4 thunderstorms, so very, very bad thunderstorms with heavy rain, or higher level thunderstorms. So this is quite significant convective weather along your route. Non-convectors are issued for areas when there are severe turbulence, severe icing, or where there's a large area of IMC exists due to volcanic ash, sand, or dust. Now, if a pilot doesn't encounter or find anything on the SIGMET report, but en route he does discover that there is some significant weather, a pilot who encounters significant weather en route or significant meteorological hazard is recommended to make a special air report, and that's simply by broadcasting to the ATC that you're in contact with the significant weather that you're experiencing. So this is what a general SIGMET looks like. It contains the location. So if we look at the example at the bottom, you've got FACA, which is the Cape Town Flight Information Region. It's the type of message, so it's a SIGMET, and then your A03 is just the sequence number. It's got the validity, so how long is this valid for? So it's from the 11th at 12 o'clock Zulu to the 11th at 1800 Zulu. And the issuing office, so FAOR, which is OR International Airport, will have issued the SIGMET, and then it will be for FACA, so it will be for the Cape Town Flight Information Region, and it's got severe mountain waves forecast within, and then it gives you the coordinates where you will experience this severe mountain waves. So this is a basic SIGMET, and as mentioned, it can either include severe icing, turbulence, volcanic ash, or convective weather. Okay, let's have a look at the AirMet. So the AirMet is the Airman's meteorological information and covers less severe weather than SIGMET, and reports on moderate turbulence or icing or sustained surface winds of 30 knots or more and widespread restricted visibility. So an AirMet is very similar to a SIGMET, though it reports less severe weather. Okay, it's valid for a longer time period, so valid for 8 hours, and it's issued 4 times a day and has an outlook period of 6 hours and is a forecast of up to 10,000 feet. Okay, aviation weather broadcasts. Now, a pilot cannot retrieve any weather reports in written form during flight. The only way to get a weather report or forecast or any other information is via radio telephony, and there's various ways to obtain that. So one way is to obtain a weather report is to ask the air traffic controller you're in contact with. So you can just contact them and ask them for the latest surface conditions at the specific airport that you're going to. You also get something called a VOLMET. So the VOLMET will broadcast continuous and repetitive METARs, species, TAFs, and SIGMETs. However, it's for a selection of aerodromes within the vicinity of the or in the flight information region, and it's transmitted on a VHF frequency or an HF frequency. So it's a specific frequency you set, and you'll be able to listen to a specific airport. However, it does contain more than one airport's weather information. Okay, then an ATIS is what stands for the Automatic Terminal Information Service, and is a service that's provided at some airports, which gives you the latest surface conditions and information. So it's very similar to the VOLMET. However, an ATIS is for one specific airport. It is a continuous broadcast of recorded aeronautical information. So it can be a radio frequency, which you set, and you can listen to an automated voice continuously repeating this information, or it's a telephone number that you can phone so that you can minimize VHF frequency use. So ATIS can also be broadcast on a VRR frequency as well. So the weather information provided is very similar to a METAR for a particular airport, but it can also contain information with regards to the safe conduct of your flight at that airport. What I mean by that, it will give you the METAR, but it can also tell you that there's increased bird activity at the airport, or work on a certain taxiway, or air traffic controllers are in training. So this is an example of an ATIS. So it will read over the radio once you tune the frequency. So Cape Town Information, International Information Alpha. This information is updated every 30 minutes as well, and then it's given a new letter of the alphabet. So 30 minutes later, this will be Cape Town International Information Bravo. The time that it was issued, 1230. Expected SIDS and stars in use, zone VMC. So the zone or the weather in that area is visual. Runway 01 for arrival and departure. Transition level 9 Wind is 350 degrees, 12 knots. Visibility is 6,000 meters. Present weather, rain, scattered cloud at 1,800 feet, overcast at 4,300 feet, temperature 16, dew point 14, QNH 1011, tempo visibility 4,000 meters, broken cloud at 800 meters. It can also give you information like ATCs in training, as mentioned before, or there's work in progress on taxiway Charlie, and that taxiway is closed. So information provided by the ATIS includes the airfield's surface wind direction and speed, and given in degrees magnetic. So very importantly, at the beginning of the METARs, we discussed that the wind direction was given in degrees true, and on the ATIS though, it's given in degrees magnetic because of the runway direction. Gives you QNH, visibility, and the runway in use. So a rule of thumb, anytime the wind is written, it is in degrees true. Anytime the wind is spoken, it is in degrees magnetic. Now the ATIS is usually updated every 30 minutes, and a new letter from the phonetic alphabet will be assigned for each update. So we already discussed this. So initially we'll start with Alpha, 30 minutes later with an update would be Bravo, and so on. Let's have a look at a few exam examples. So it says this is a METAR for Cape Town, and it is issued on the 22nd at 5 o'clock Zulu. The wind is 010 degrees, 80 knots, gusting 32 knots, visibility greater than 10 kilometers, scattered cloud at 2,000 feet, broken cloud at 3,500 feet, and your temperature is 12, dew point is 9, no sick. So the lowest cloud is, so looking at our cloud information, the lowest cloud will be scattered cloud at 2,000 feet. So the answer is 3 to 4 octaves, which is scattered at 2,000 feet. Okay, the term CAVOK used in a TAF or METAR means visibility greater than 10 kilometers, no cloud below 5,000 feet or minimum sector altitude, no cumulonimbus clouds, and no significant weather. So the answer they're looking for is visibility is 10 kilometers or more and no cloud below 5,000 feet. A sudden change in visibility, low cloud, surface wind or weather is provided for in air. So a sudden change would definitely be a specie. Here we go. That's the answer, a specie. In the TAF for Athens during summer, for the time of your landing, you note tempo TS, which is temporarily thunder showers. What is the maximum time this deterioration in weather can last in any one instance? So very important, when we refer to temporarily, the fluctuation in weather is temporary. This fluctuation won't last more than 1 hour. And altogether, if it gives you a time period, together this fluctuation won't last for more than half the forecast period. So this is asking the deterioration in weather will last in one instance. So they're probably referring to the fluctuation in one instance. And that is less than 60 minutes. So it won't last for more than 1 hour. Okay, that's all for this video. Thank you for watching and see you in the next one.